Right. Good morning,
Hello,
grade
grade
11s.
11s. What I'm going to do is I'm going to do the... no. Okay, I'm going to carry on from there. I'm going to do the memo to the trig consolidation test. Even though there is a memo, I thought if I went through it with you and explained as I was doing it, for some of you it might make a little bit more sense, okay? All right, so the first question asked us to simplify the cos of 74 degrees times the tan of 120 degrees times the cos of 315 degrees. And as I'm writing this, I'm saying, hang on, these angles are bigger than 90 degrees. And as soon as I have an angle that's bigger than 90 degrees, I know I'm going to have to use reduction formula. And what does reduction formula say to me? Reduction formula says what quad, what sine, and then write down the acute angle. Okay. The answer to this, it also said we must leave it in surd form. So let's have a look and let's start. All right. The cos of 74. It's already an acute angle. I'm going to do absolutely nothing with it. All right. Tan of 120. First thing I ask myself is what quad am I in? 120 is in the second quad. What do I know about tan in the second quad? It is negative. And in the second quad, remember, it's always going to be 180 degrees minus theta. Must get me to 120. So I always go 180 minus 120, which gets me to 60 degrees. Okay, cos of 315. Cos, it's in the fourth quad, it's positive, agreed? And remember, in my final quad, it's 360 minus theta. Remember, theta is an acute angle, must give me 315. I just go cos of 360 minus 315, and that will tell me that it is the cos of 45 degrees. Right, at the bottom, sine of 210. What quad am I in? I'm in the third quad. Okay, now in the third quad, it's 180 degrees plus theta must give me 210, i.e. 210 minus 180, which will give me the sine of 30, but I must remember that sine is negative in that quad. Okay, all right, let's just put this in all students. Take care. All right. Okay, cos of 106. I'm in the second quad. What do I know about cos in the second quad? It's negative. Cos 180 minus 106 gives me 74 degrees. Okay, now that already, grade 11s, is literally a mark for that, for that, for that, and for that. So just by doing your reduction formula, you're getting mega marks. Okay. All right, now we can go and see if we can simplify. Okay. Oh, cos 74, but I'm still left with a minus 1. As soon as I see 60s, 45s, and 30s, I know they're special angles. Please, you don't have to know these off by heart. You have a calculator. You go into your calculator and you press tan of 60, and it will give you negative, or it will give you root 3. Cos of 45, you go onto your calculator. It will give you root 2 over 2. Right, sine of 30, put it into your calculator, and you will get negative a half. Okay, now, if I look at this, I can see I'm dividing by a fraction. So if I'm dividing by a fraction, I'm just going to put that over 1, times by root 2 over 2, I know that to divide by a fraction, I'm going to tip and times. My 2's are going to cancel. My minus times my minus is going to give me a plus, and I'm going to be left with root 3 times root 2, which I can then write as the root of 6. Okay, and I've left it in surd form. Right. Question 1.2.1 asked me to prove that negative tan squared theta all over cos of to the power of 4 of theta minus 1 was equal to 1 over cos squared theta minus 1 over cos squared theta plus 1. Right. Now this is an identity. They're basically saying to me, prove that the left-hand side is equal to the right-hand side. Okay. So let's start, and it doesn't matter which one. I always say start with the most difficult side, but it really doesn't matter, and sometimes you have to work with both sides. So I'm going to start, and remember I write down left-hand side equals. Okay. All right, now I've got negative tan squared. What do I know about tan? Tan is going to become sine squared theta over cos squared theta. Okay, then I'm just going to make a line over here. I've got cos to the power of 4 theta minus 1, which we should recognize as difference of squares. So it becomes cos squared theta minus 1 and cos squared theta plus 1. Okay, now this looks a little bit yucky to me because I've got a fraction over something. So why don't I rewrite it and go, right, it's negative sine squared theta over cos squared theta. Then at the bottom, I am dividing by that. So what can I do? I can tip and times. So it will become cos squared, I'm sorry, I'm lying to you. It's going to be the other way around. Sorry, I like to lie. Okay, let's go back to pen. All right, so it's going to become 1 over cos squared theta minus 1 times cos squared theta plus 1. All right, now what am I going to do? Okay, all right, now remember that there are a couple of things that we should know off by heart. We should know that the tan of theta is equal to the sine of theta over the cos of theta. We should also know that sine squared theta plus cos squared theta is equal to 1. Or from that you can say sine squared theta is equal to 1 minus cos squared theta, or cos squared theta is equal to 1 minus sine squared theta. Okay, and these we need to know off by heart and keep looking for where we can use them. Okay, all right, now if I look at cos squared minus 1 and I look at 1 minus cos squared, they're not the same, but can you see that they're switcheroos of each other? So do you agree with me that I could go and write this now as negative sine squared theta over cos squared theta times by 1 over, now for switcheroo it's going to become negative sine squared theta times by cos squared theta plus 1, and that's going to help me because now those two are going to cancel and I'm left with 1 over cos squared theta times cos squared theta plus 1. Okay, so I've done my left hand side, but that's not going to help me at this stage. I've now got to look at my right hand side as well. Okay, so if I look at my right hand side, let's see what I can do on my right hand side. All right, on my right hand side I'm adding and subtracting fractions. So when I'm adding and subtracting fractions, I need to find a common denominator. Right, so if I needed to find a common denominator here, it has to be cos squared theta and cos squared theta plus 1. Remember, everybody's got to go into it. So if I divide the first fraction into there, I'm left with cos squared theta plus 1 minus, I divide the second one into there, I'm left with cos squared theta, and if I simplify that, I get 1 over cos squared theta times by cos squared theta plus 1, and lo and behold, what do I see? Therefore, my left-hand side is equal to my right-hand side. And I have proved the identity. Okay. Right, question 1.2.2 says to me, prove to me that it cannot be equal to 90 degrees. Okay, now, if I've got something in the denominator, so cos squared theta, anything in the denominator, thou shalt not divide by 0. So we know that's not allowed to equal naught, i.e. the cos of theta is not allowed to equal naught. Okay, think about what a cos graph looks like. There's just a very basic one. Look at that point there. Okay, at 90 degrees, what do we notice? Cos is equal to naught, and therefore theta may not be equal to 90 degrees. It also is not allowed to equal to 270, but they didn't ask us that.